Okay, so what we're going to be talking about today is percent yield. We're still going to be solving stoichiometry problems, but this time we're going to be looking at comparing the actual amount produced with what we calculate. So stoichiometry is a calculated value, all right, what we call the theoretical yield. So in order to calculate percent yield, it is actual yield divided by the theoretical yield times 100. So this will always be given, and this is going to be what we calculate. All right, so let's put this together. So what you're given is 49 grams of H3PO4. I know not to use this one because notice it says to determine the percent yield if you isolate. So that's a product. That's what I'm looking for. So 1 mole of phosphoric acid is 98 grams, okay? And then go to your mole ratio. 1 mole of potassium phosphate, that's what we're looking for, over 1 mole of phosphoric acid. Calculate your mass of this, which is 272 grams of K3PO4. 1 mole of K3PO4. And what this is going to do, all this cancels out, just like we've done in the past, and I should get a yield of 106 grams. All right, so this is my theoretical yield. So now use this value, 49, that is my actual yield, divided by my theoretical, my calculated, times 100, and I'm going to get 46, roughly 46%. So that means, and if you look, that's not a very high percentage compared to what we actually should get. So in chemistry, we want a very high percent yield. So this would not be very productive. All right, let's look at the next one. So here I'm given, and I want you to solve this stoichiometry problem. Solve it. Don't use this until the end, but pause the video and see if you can do this example on your own. Then come back and check your answer with mine. All right, so let's start with this. So 50.3 grams of aluminum hydroxide. All right, so get the mass. 1 mole is going to equal 78 grams of aluminum hydroxide. All right, I'm looking for this. So 3 moles of H2O. This is what I had. 1 mole of aluminum hydroxide. Change this to grams, so 18 grams of water over 1 mole of water. All of this good stuff cancels out, and I am left with 34.8 grams of water. Okay, so this is my theoretical yield. Remember, actual yield divided by theoretical yield times 100. So my actual yield is 25. So 25 grams divided by 34.8 times 100, I should get roughly 71.79%. Okay, so that's how you do percent yield. I want to show you one more type of problem, because if you look here in this one, it gave us the percent and not the actual yield. So there's a little bit of trickier way of solving this. So once again, for practice, go ahead and set up the problem. All right, and then come back and see if you did it correctly. And then I'll show you how to do the other part as you're watching the video. So we start off with 389.4 grams of aluminum sulfite. All right, change that into moles of aluminum sulfite. All right, which is going to be, so the mass of this is 267 grams. All right. Now, I am looking for this. So 3 moles of sodium sulfite. over, this is what I was given, 1 mole of aluminum sulfite. Change this to grams. All right, and that's going to be 126 grams of sodium sulfite over 1 mole. So all this stuff cancels, and I am left with 551 grams of sodium sulfite. Okay, so here's where it's going to be a little different. You know your percent, so I want you to write that down, move your decimal like if you hadn't multiplied it by 100, so 82.57. We don't know the actual yield, but we know our theoretical to be 551. All right, so if I go and I multiply, if I multiply both sides by 551, okay, so 551 times 0.8257, I'm going to get 454.96 grams. So what I made, my actual yield, is 554 or 555 grams. So sometimes you're going to be given the percent value. Other times you're going to be given the actual yield. So you're going to be doing one of two things. You're going to be determining the percent or the actual yield. Okay. This you will always have because you're going to calculate it. So it just depends on if you have this or if you have this, which type of problem you're going to do with percent yield.